Okay, so let's start now. So, the first thing I would like to tell you is that suppose we have a spring, okay? So, okay, so suppose we have a spring like this and it has a length Li, initial length, and then when you apply a force onto it, the length basically increases and becomes uh, and it becomes Lf. So this length, that extension that is caused by this force, let's call this x. Okay, so x here is the extension, and the extension is basically caused by Lf minus Li. Do you guys understand this? Now, generally this length can be negative or positive depending on what's really happening. What I mean by that is that either when the force is applied outwards, so in this case, whenever you will find, you will get a positive extension, which means that it indicates that object is deformed due to tension, which is basically, tension is the pulling force, as we studied before as well. However, if the same object, which was like this initially, Li, and now it is compressed because you pushed it like this, so its new length is gonna be Lf, and now this is the extension. So when you find the extension is gonna get negative, which basically means that this negative indicates object deformed in compression, and compression is the pushing force, like that. Is it clear, everybody? Please let me know if you have a question. Okay, pretty good. Expecting this to happen. Okay. Now, now let's look at what exactly do I mean by tension, force, and compression force. So tension basically is a force that tends to increase the length of a body. Okay, what I mean by that is that basically it's an outward force and the outward force makes the body elongate like this. So tension is like on this side, where compression is a force that compress or push inwards. So basically the object is made to basically clamp together, push together like this. Is it clear, Aman, Aisha and Raman?
Yes, sir.
Okay, pretty good then. Right. Okay, please, you can write it down now. Okay, now, so all of this that we're doing basically is related to a law which is basically called the Hooke's law. And Hooke's law has a definition, it will always be asked to you. So it states that the force is directly proportional to extension, which is also sometimes regarded as change of length, right? You can remember both of them. Unless a limit of proportionality has not reached, which means there is some point limit proportionality during this time, and if that is not reached, it just stays like that. Okay. Okay. Now, so generally in your exam you will find extension symbol. I wanted to bring this out because this is important. Generally, I'm speaking that the notation of extension is either E or it is delta X or just X, right? So do not get worried if they give you any of these, this just means the same thing. Now what they are actually pointing out is that basically force is directly proportional to extension, and when you remove this proportionality sign you get Kx, where K is the spring constant. You need to introduce a constant then, and spring constant is basically defined as the force per unit extension, right? So the SI units of spring constant is Newton meter, and the most important thing about this is this actually depicts how stiff a material is, which means that if the value of K of a certain material is higher, it means you will have to put a lot of force to extend it to the same amount with respect to another material which has a lower spring constant. Do you guys understand what I'm saying? Now generally, you can write this down and then we'll move forward. Okay.
Sir, what does this say? Depict how stiff
Depicts how stiff a material is.
okay.
Okay. All right. So before we just a second, please. Okay. Now, so before we go on to check out its graph, I just want to point out few things, and these are basically not required really. You can or may not draw, it does not really matter. So there will be three different words that they're going to use. The first one they're going to use is directly proportional, and then they're going to use proportional, and then they're going to use inversely proportional. So these are the three words you're gonna use. Okay. Now, okay. So directly proportional basically means that whatever graph you draw, it's gonna basically start from the origin, and it is going to be a straight line, which means like this. Okay, so it's gonna start from the origin, and it's gonna be straight line, no matter what. So if this is a graph between y and x, then the equation for the graph of the directly proportional will be y y is equal to mx, which means y is directly proportional to x. Okay. Now, when they are going to say like only proportional, it basically means that this time the line will not start from origin, but will be straight. So this will be y, this will be x, and this sort of a line which has an intercept is basically y equals to mx plus c, and the word we use is proportional. Understood? And inversely proportional, whenever you hear this word and you want to draw the graph, you should understand that then the line will be a curve downwards, and that means that this is equal to y proportional to 1 upon x, so which means this is inversely proportional. Is it clear, everybody? Any questions? Please let me know. Okay. Now, with respect to that, the definition says that the force is directly proportional to the extension unless limit of proportionality has not reached. Okay. So, which basically means that which basically means that there could be two kinds of graphs that you will see. So first graph, kind of both at the same time. So in the first graph there is force and there is extension, and then extension is on the x-axis, force is on the y-axis, so the graph would look like this. So it's going to start from origin as it's directly proportional, but there will be a time when the graph is going to curve like this, and this point you see is basically the limit of proportionality. Okay, so you can also define limit of proportionality, and as far as this is concerned, I would just like to tell you that limit of proportionality means, let's write it, a point beyond which the material does not obey Hooke's law. Is it clear? Which basically means now force is not proportional to extension any longer. Now one thing I would like to tell you that is very important, which is that if you try to find the gradient of this line, because it is going to give you change in f over change in x, so the gradient of the straight line will give you k, because it is change in f over change in x, and because it starts from origin anyway, so you can always just take one point, it doesn't really matter, the other point will always be 0 and 0. So that's a trick. As far as the other one is concerned, if they give you extension on the y-axis and force on the x-axis, so all that basically changes it. The graph will be a straight line, but when it reaches limit proportionality, it is going to curve towards x, wherever the x is, which means the extension is. So this is the limit of proportionality. Both curves are absolutely fine. Okay, I see you. Both curves are absolutely fine, and you can always use them. They can also give you this. However, if you try to find the gradient of this line now, so I just want to tell you, because it gives you delta x over delta f, so this time the gradient would give you 1 upon k, because it is giving you delta x over delta f. So just be careful about that. Always do f upon x and you will get the right value for k. Understood?
Yes.
Okay, very good. Now there is going to be a third type of graph, and that graph is highly important. Let me just open the okay. So a third type is the graph between force in newtons versus length of spring, or material, whatever they give you, right? Doesn't really matter. So I just want to tell you that this kind of graph will always be like, here they will give you length, and here they will give you force. And usually this graph will never ever start from 0 really. It will start from some other value, so it's gonna be, okay, wait a bit. It's gonna look like this, okay? So it will have some value here. So I just want to tell you that this graph up till this value, it basically means unloaded length, which is also sometimes called the original length, because it means that when the force was 0, there was no extension, so it must be the original length of the spring. And after this, whatever the length is shown, it means this is the change in length due to the force. Is it clear, everybody?
Sir, can you repeat?
Yes. Aisha, if you look at this part, right? Only this part here. So at this part, you see 0 force, but you see some length, right? Right here.
Yes.
What does that indicate? That indicates that when there was no force applied, there was some length, right? So this length would mean that this is the length of the spring when there was no load on it. Do you understand?
Yes.
Which basically means that this is the original length of the spring, whatever it looked like when you had it without the load. But when you put the load on it, it basically extends, which means that the line is going up and there is a change in length happening due to that force. Understood?
Yes, thank you.
Okay. Now we also need to basically be aware of the experiments that we need to do to find the value of k. So we're gonna check that out. In 10 minutes when the meeting ends, please rejoin, okay? Experiment to find spring constant k. Okay. So what we want is we want a stand actually. On that stand, we gotta of course hang a spring, and then underneath this we need a mass hanger. I'm gonna label this too. And then from other hand, we also need to place a ruler such that we need to take the lengths. Okay, this is the ruler, meter rule. Okay, so this is our stand, this is spring, this is a mass hanger. You guys have done any experiments at school?
Yes.
Okay. So on that mass, we generally add slotted masses like this. Okay. just to increase the mass, right? Like that. And that would increase the extension as well. Okay. Alright, now check this out, please. So, first of all, what you're gonna do is you're gonna check the length of unloaded spring is measured using a meter rule, and let's call this basically length LO. Okay, let's call that. Then slotted masses are added of various values to measure the loaded length after each increment, and that would cause it to be Li. Okay, that length. Now then, what you're gonna do is you're gonna draw a table, and the table should look like this. I'm putting any values, but let's just draw it like this. The minimum values generally you want to take is 5 to 6. Should remember that. So basically what you need is you need a serial number, which means 1, 2, 3, 4, 5, 6, the number of experiments you've done or the repetitions. You need mass, which you added in kg. You need force in newtons, because you want to add the number of you need to calculate the force. You can do it by mg, and then you also have the unloaded length. Of course, that's the one when there was no mass, in meters. And then you have the loaded length, that's basically in meters as well. And then you can find the change in length, which is the extension, by subtracting these two. Okay, so you get the extension as well. Is it clear? Any questions now?
No, sir.
Then what you're gonna do is you're gonna plot a graph of force in newtons versus, or you could say force on y-axis versus delta x on x-axis, and the graph would look like this. F and x. Now this graph obviously is going to, when you plot the points are going to be something like this. So you're going to draw a line of best fit. The line of best fit should start from the origin. It will be a straight line like that. So draw the line of best fit. And I just want to point this out here. Best fit line does not mean that it touches any point that you've plotted. It just means that it will divide points equally on both sides of it. Okay, so you just need to remember that. And then you can simply find the gradient of the line. Okay, I need to use a different color. Usually in graphs we tend to take 2 points which are far away from each other. So then we could say that, okay, the gradient of line will be equal to change in f over change in x, which basically is k, that is our spring constant that we are looking for. Now just a small note here, just to remind you people, and that is the line always start from origin, because that's how it should be, and we've learned this too. Any questions, please let me know. Okay, Aman. Okay. Now I guess up till here we're gonna stop, and then we're gonna continue from the next class, because then we need more time to cover it up. Okay, Aisha.